Hello everyone, welcome to today's session. Today's topic is Azure Computer Vision technology, and today's our speaker with us is Sanya Sinha. She is a Gold MLSA community lead at VOC and a regional Azure developer lead and Twilio Scholar 21 Azure Hero author AI ambassador. Means such a huge achievements and such a huge responsibilities Sanya have. So yeah, means let's welcome Sanya Sinha. So today's session we are going on Azure Computer Vision technology and how it is changing the today's world. So yeah, all up to you, Sanya.
Thank you so much, Anubhav, for that introduction. So, hi everyone, I'm Sanya. So, let me just start sharing my screen now. Um, just one second. Can you please confirm if you can see my screen?
Yeah, currently yes, we can see.
All right, thank you. So, welcome to the Computer Vision Workshop, everyone. I'm Sanya, and I'm a Gold Microsoft Run Student Ambassador, an Azure Developer Lead, a Video Signal Scholar, an Azure Hero, an AI Ambassador, as well as an upcoming summer research intern at the University of Texas in Austin. I'm extremely passionate about artificial intelligence, particularly computer vision. So I really hope that you enjoy this workshop as much as I enjoy teaching you all. So without any further ado, let us just get started. So, what is computer vision? Before we begin with the workshop, I think it's absolutely mandatory for all of us to know what computer vision actually is. So, computer vision is a field or a branch of artificial intelligence that enables computers and systems or machines to derive meaningful information and insights from digital images, videos, and other visual inputs, and then take actions or make recommendations based on that information. So this is a pretty good definition for this that can actually sum up what computer vision actually is and what it actually does. But I have another example that will probably help you understand this better. So when I look at a dog, I am actually able to recognize that okay, this animal is actually a dog. This is because I have actually seen the images of dogs before in my life, right? However, if you suddenly show the picture of a dog to a computer, do you actually believe that it would be able to visually understand that this image belongs to that of a dog? It's not feasibly possible, right? It's not very feasible for it because it hasn't really seen what dogs look like in real life. So this is what computer vision is actually based on. It says that if your computer can actually be trained on dog images, it would then be able to recognize dogs and identify them, right? Similarly, if you're talking about cat images, if you train your computer to recognize cat images, it would do as you say. So this is what computer vision is actually about. It receives data, it receives visual inputs from the users, and then it is able to perceive things visually just the way humans perceive things. So, computer vision is a very revolutionary field that has actually been revolutionizing artificial intelligence and the way we do day to day activities. So, one of its prime areas of application has been the field of transportation. So, computer vision is often amalgamated with transportation to give rise to something known as intelligent transportation systems, or ITS as they're called. So, all your upcoming technologies like self driving cars, or traffic signal priority, automated vehicles. So, all of these are possible only by using computer vision. For example, if we're talking about something like traffic signal priority, so traffic signal priority basically seeks to give more priority, or whenever you have a traffic jam or something. So, public transportation vehicles and vehicles of higher priority, like police vans and ambulances, fire trucks, etc., they are given more priority. So, traffic signal priority basically seeks to use us computer vision enabled CCTV cameras to actually understand that, oh, all right, this is an ambulance, this is a fire truck, and it seeks to clear the line for them and allow lane traffic control to actually let these vehicles pass while stopping the other vehicles from passing. So, this is a very good example for the implementation of computer vision in transportation. So, next up, we have medicine. So, computer vision has actually revolutionized medicine or the field of healthcare also significantly. So, particularly, this gave birth to something known as automated diagnosis, wherein your machines or your computers can actually diagnose diseases that manifest changes in the organs visually. For example, if you have diseases like brain tumor, breast tumor, melanoma, malaria, diabetic retinopathy, glaucoma. So all of these diseases actually manifest some changes in the visual anatomy of the organ or of the person, that of the particular individual that we are talking about, right? So because of any visual anomalies or outliers that can be detected by using appropriate imaging systems, computer vision can then classify that, all right, this particular patient is suffering from brain tumor or not, based on the data that it has been provided with and based on the data that it has been trained on. For example, if we're talking about diabetic retinopathy, so if I feed retinal fundus images into an application, into a computer vision enabled application, it would actually be able to make out things like exudates and lesions, and it would then be able to report to the patient or to the doctor who's actually using them that, all right, due to the presence of these anomalies, this particular patient has this much probability, has a 90% probability of actually being diagnosed with diabetic retinopathy. So this is how you can use computer vision in medicine. So another application for computer vision could be in the field of security. So you have features like retinal recognition or face recognition features, face alarm systems. So all of these actually encompass the applications of computer vision in the field of security. And next up, we have an application of computer vision in retail. So I think the best example for computer vision in retail could be self checkout counters, wherein these checkout counters can actually allow you to complete your transaction without any manual intervention needed. So every time you go to a self checkout counter, your CCTV, computer vision enabled CCTV cameras will actually be able to recognize all the different items that you have in your basket or in your trolley, and then it would be able to recognize them separately. It would be able to associate price tags with each of these, and then based on that, it would be able to calculate your entire bill, how much tax is going to be deducted, and so on. So you can see that computer vision basically encompasses a very broad spectrum of day to day applications, and therefore it has a lot of scope in the future, and a lot more research work is being done to actually make computer vision God's own thing. So now we are going to be talking about the computer vision API that has been brought to you by Microsoft Azure. So, if you are familiar with deep learning or machine learning, you would know that actually enabling a computer vision service using either convolutional neural networks or by using the OpenCV library is actually a little time consuming, especially if you're using deep learning methodologies. This is because it actually contains a lot of code that has to be written. Moreover, it's actually very difficult when you actually have to run it on a GPU or an external TPU and so on, because of the limited computational capabilities available on your system, right? So by using Microsoft Azure's custom vision API, you reduce the need for dependency on any local machinery or on any local infrastructure, because everything that you are doing is being done on the cloud. And besides that, even the code that would have traditionally been about 1,000 to 2,000 lines is actually reduced to roughly 50 to 100 lines of code only. So this is how amazing Microsoft Azure's computer vision API actually is. And these are the numerous features that it provides. So features like text extraction or OCR, optical character recognition. So they extract printed and handwritten text from images and documents with mixed languages and writing styles. Then it enables you to perform something known as image understanding. It will be able to pull from a rich ontology of more than 10,000 concepts and objects to generate value from your visual assets. This means that if it looks at an image, for example, if it looks at an image of a man throwing a frisbee at a dog, it would actually be able to identify the different tags associated with that image. For example, dog, frisbee, man, if the person is in a park, so the trees, throwing, playing. So your computer vision API has actually been pre-trained, and all you have to do is that you need to put up your tested data so that actually that it can actually predict this is what your image is actually trying to convey to you. So another example, another application of computer vision API is spatial analysis. So you can analyze how people move in space in real time, particularly for video based inputs, for occupancy count, for social distancing, and face mask detection. So it is also really amazing when you're working in with respect to the COVID-19 protocol that is actually prevalent in today's life extremely. And then you can actually use the spatial analysis option of the computer vision API to actually understand the various distancing protocols, the occupancy count of a room, whether the social distancing protocols are being dealt with or not, and so on, just by using the spatial analysis option of the computer vision API. And the next, possibly one of the best examples of the computer vision API, or one of the best use cases of the computer vision API, is its flexible deployment. So this is because you're actually running the API on a cloud, and it can offer you umpteen upscaling, umpteen flexibility. You have complete flexibility, you have complete control over the resources that you're using on the cloud. You can run your resource either on the cloud, you can run it on the edge, you can even run it in containerized applications. So it completely depends upon you whether you know how much resources you are going to be using or not. If you think that you are going to be using a lot of compute, you can definitely do it on the cloud or in your containers. So if you're not familiar with containers, containers are basically like packets of code with dependencies, and basically a packet of everything that you will need to actually deploy your application. So this is what the computer vision API brought to you by Microsoft Azure actually is. And this is why it is so much better than using just your traditional deep learning methodologies. So if we talk about the computer vision API that I had just talked to you about, so important implementations for this could be writing low code with diverse functionality. So as I said, it can actually reduce the amount of code that you're writing significantly. If you were writing, supposedly, let's just say 1,000 lines of code using the computer vision API, you would be left with just just 100 lines of code. So this is how it actually simplifies the process of writing. Next up, you can create OCR or text recognition, facial recognition, and object recognition applications. Moreover, applications for spatial analysis, which can actually help you to understand the text that is being fed into it. You can even enable it to recognize faces, recognize objects, and so on, just by using the computer vision API. Next up, your computer vision API has already been trained with almost everything, with almost every possible object in the world. For example, a data set like ImageNet or SSD mobile net. So these data sets have already been used to train the computer vision API, so that your computer vision API can actually detect almost every possible image that you subject it to. It contains about 14 billion images, 14 billion classes of images that can actually be used to detect or recognize different objects that you are going to be testing your computer vision API with. And next up, as I told you, you can containerize your applications. You can deploy them either on the cloud or on the edge or on the computer or on the cloud or on the containers. It doesn't really matter. You can deploy them anywhere with as much flexibility as you would like to have, and with as much scalability as is required for your application. So now we are going to be dealing with a very simple workshop based on your computer vision API. So this is using the computer vision API for image description. So what we're actually going to be doing is that we are going to be feeding an image based on your computer vision API. And then I would actually want my computer vision API to return an output based on a description of what it actually thinks my input image is about. For example, if I feed an image of a dog, I want my computer vision API to print something like this is a dog. So I want my computer vision API to actually describe the image that I am going to feed into it. And this is one of its best functionalities that I can talk about, that I can definitely teach you about. And I guess that it's really very important for all of us to work on this project. So if you want to work on it with me simultaneously, you can. It's actually a really simple project. All you need for this is an Azure account. So if you don't have an Azure account, you can just one second. I am just pasting this URL over here to show you what it actually does. So you can create an Azure for Students account over here. And just one moment. Yeah, you can create an Azure for Students account. It will enable you with $100 worth of Azure credit with no credit card required. This is liable for, I think, for a year or so. So if you can get this version just by applying with your email ID, with your college's email ID, then I think there is nothing better than that. Also, if you're not a student and you would still like to work on this project, I would advise you to opt for the free trial version, which enables you to use all the free resources of Microsoft Azure for a limited period of time. So yeah, I think this is really great. And so once you have created your Azure account, you need to log into your Azure portal. So an Azure portal looks somewhat like this. And on the Azure portal, you have various services that you can create resources on. So in this example, we're going to be creating a computer vision resource. So in order to save time with your project, I have actually created a video of it in order to show you what actually is it like to create a computer vision resource. So once you open your Azure portal, you're going to click on computer vision right over here, and this is the page that appears. So I don't have any computer vision resources to display, so now just click on create. That appears right over here. So now we're just creating a particular resource especially for the purpose of computer vision. So my subscription for this was Visual Studio Enterprise. You can actually use whatever subscription that is being made available to you. You can actually check out the subscription that you're using by logging into your Azure portal and clicking on subscriptions right here, and it actually gives you the name of your subscription and your subscription ID. All right. So let me just reopen this video again. Yeah. So click on computer vision. This is the page that gets displayed, and now click on create so as to create a new computer vision resource. So it's actually creating a new resource. The subscription is Visual Studio Enterprise. If you have a resource group already created, so all your resources, whether it is going to be a custom vision resource or a computer vision resource or a cognitive services resource, all your resources must be created within a resource group. So if you already have a resource group created, you can just click on this drop down menu and select one. And if not, you can just click on create new and type the name of the resource group. So a resource group is a container that holds related resources for an Azure solution. So you can just name it whatever you like. I think I've named it something like CV landmark. Yeah, this is what I have named it. And now you have to create an instance within your resource group. So basically, your instances are created in brick and mortar Azure data centers. So since it is actually going to be fetched from the data center, since the instance is actually going to be fetched from the data center that is nearest to you, I would suggest to actually create the instance in a nearby data center only. For example, currently I am in central India, so I should not be creating a resource in East US, because then it would naturally complicate my entire resource fetching purposes entirely, right? It would actually complicate and make the purpose a lot more complex than it actually is. So therefore I would advise you to actually create your instances in regions that are near to you. Now once you've specified the location of your instance, create a new or define a new name for it. That in my case was CV landmark demo 101. Select a pricing tier. So you can either select a standard tier, which allows you for 10 calls per second, but I think it would be better if I could just use the free tier, because it gives 20 calls per minute, and I don't think that I am going to be using more than that for the time being, and plus it's cheaper, right? So it gives you 5,000 calls per month. You can use it for 5,000 times, and it gives you 20 calls per minute. So this is actually kind of nice. That is actually a feasible solution. And once you are done with it, there is a checkbox over here that you'll have to check about responsible AI, and finally click on review and create. So now it will run a validation of whether you have entered the whether you've entered suitable basic features or not. And once it has actually rectified your basic features, it would pass your validation, and it would begin with the deployment of your computer vision resource. So let's just wait for it to get deployed. It actually doesn't take a lot of time. Let me just fast forward the video a little. So the deployment has succeeded. You can just log into your resource. You can just go to your resource, and then now that you are with your resource, you need to navigate to the resource management pane that is located towards the left hand side of the page. And then over here you can see keys and endpoints. So these keys and endpoints are actually specific to your resource itself. And actually, whenever you're using, I would encourage you to use your own account and not mine. And plus I would actually be deleting this just after my workshop ends, so that you're not able to use it. And I would encourage you to actually work on this project on your own and not use the keys and endpoints that are given over here, so for security purposes. So once you have access to your keys and your endpoints, I would suggest you to actually create a new notepad file and store them over there, so that you can use them whenever required. So this is how you can create a computer vision resource on your Azure portal. Now that you have created a computer vision resource, it's time to start coding. So what we're actually going to be doing is that this is an image that I have. I got this from the internet, and I am actually going to feed this image into the computer vision API's application, and I'm actually going to see whether it is able to describe this image properly or not. So let's take a look at the code that is responsible. So in order to use the computer vision API, you'll have to copy this particular installation, that is pip install Azure Cognitive Services Vision Computer Vision. And once you have copied it, you can just paste it in your terminal. So I'm using the Visual Studio Code text editor for this. You can use any text editor of your choice. So once you're done with it, it says requirement already satisfied because I already had these features with me. And now let's get start talking about the code. So as you can see, this is just 20 lines of code. This is actually a really simple code for something that is so complicated. So first of all, I'm importing the input output modules. I'm importing JSON. I'm importing requests that actually helps me to deal with HTTP requests. Then from MS REST authentication services, I'm importing cognitive services credentials. Now, what are credentials? So credentials basically contains my API key and the endpoint that I'm going to be using. So you'll have to create a new JSON file with the name credential. You can choose any name that you want. I've chosen credential. And inside this JSON file, you need to store the API key and the endpoint that you had copied into your notepad file. Fine. You can actually just copy them here also directly. It doesn't really matter. So from your authentication services, you'll have to import the cognitive services credentials facility. And from Azure's cognitive services, Vision's computer vision services, you'll have to import the computer vision client. Also, from Azure's cognitive services, vision services, computer vision services models, we're going to import the operation status codes and the visual features types. So that is actually able to tell you what are the features that we're actually going to be extracting from your input image. Next up, I'm importing pillow because I had thought that I would use it, but I didn't actually. So it doesn't really matter. You can just skip this altogether. So now we are going to create a new variable called credential, and within this variable credential, I am actually going to store this JSON file that I had created called credential.json, which actually contains my API key and endpoint. Please don't use my API key and my endpoint. Um, and then once you have the credential file created, click on json.load. Sorry, you can just load this JSON file into this variable credential. And next, you can define your API key and your endpoint by fetching it from the credential JSON and by selecting the particular row's API key and endpoint from the JSON file that you had created. Next up, from your computer vision client, if you want to know about something, just hover up to it. It's a state of the art algorithm to process images and return information. So we're going to select endpoint, and from the cognitive services credentials, we're going to select API key. And I'm going to store all this into a variable called CV client. Now I have actually created two image URLs. The first one was for the forest example that I had shown to you. I've just taken two random images from the internet. You can choose any image that you like. So this was the image that I was talking about. This is a forest. This is a road. So let's just see what more do we have to do. So this is image URL 1. I have set the number of maximum descriptions to 3, which is actually quite a suitable number for a descriptive amount. And next up, from my CV client, which was actually created over here, I am going to import the module describe image so that it actually helps me to bring a description of the image in human readable language with complete sentences. And so from the CV client, I'm going to be fetching describe image, and the image that I want to be describing is the one that is stored in the variable image URL1, which was my forest image. And the next parameter that I'm going to be specifying is the max description, which in my case was set to 3. And now I am going to be printing the response. And now so once you already have the response, there are some other things that I like to print, and that is for caption and response captions. I'm going to print the image description, and I'm going to print the confidence with which my computer vision API is telling me that, all right, this is exactly what I am saying it is. This image contains what I'm saying it is. And once you are done with this, just hit run. So as you can see, in image description, it actually says a dirt road through a forest, which is actually true. How else would you describe this? I think I'll describe it as a dirt road through the forest, which is actually correct. And you can check that it has a 44.295% confidence regarding the fact that, all right, this really is a dirt road through the forest. You can also take a look at the various tags present here. So that it's actually able to recognize all the different objects or all the different features that could be associated with the image that we were talking about. So whether it's a tree, whether it's outdoor, whether it's ground, plant, forest, wooded, park, wood area surrounded. So these are the different tags that were associated with this particular image. Now we can take a look at another image. So let's take a look at this image. Let's see what this image actually is. All right, this is the Eiffel Tower, and there is another small tower over here as well. So let's just see how this reads it. So over here, instead of printing image URL 1, I'm just gonna print image URL 2 because that is the image that is stored over here, right? I'm just gonna save it and I'm just gonna click on run. So let's just see what output it turns. So as you can see here, it says a tall tower lit up at night with Eiffel Tower in the background. So you can see how amazing the computer vision service actually is, because not only is it able to identify a tower, but it's actually able to even identify a specific tower by the name of the Eiffel Tower. So this is how amazing your computer vision API actually is, and this is how awesome is its implementation. It just took about 20 lines of code, that too about 8 of them, 7 of them were just about importing cognitive services, importing computer vision, importing the operation status codes and visual feature types and so on. And the remaining was just about fetching your API key and your endpoint. And just in, I guess, in about one single line, which was CV client or describe image, you were able to return a description of the image that you fed into your system. So I think this was all about this particular um, implementation, this particular activity. If you have any questions, feel free to drop them to them. I would be more than happy to help you out. Hello.
Yeah, you are audible. We can continue.
Yeah, I got disconnected, I think.
Yeah, no issues. It happens sometime. You can please again share your screen and then we can again start.
Yeah, sure.
Sorry, guys, for the inconvenience.
Yeah, so are there any doubts that you would like to ask? If there are any doubts, then please feel free to drop them. I don't think there are any doubts with respect to this. So we have a question from Nilay. How much freedom do we have with tuning the models using computer vision in Azure? So actually, the thing is that your computer vision model has actually already been trained on the ImageNet and SSD mobile net datasets. So you are just going to be able to feed some images into it, and then it would be able to return the images that it has already been trained on. So it's actually really good if you're actually working on regular images or general images. However, if you're actually working on a specific use case, for example, like I gave you an example of diabetic retinopathy, so it does not allow you to customize everything as well as other Microsoft Azure services like custom vision would allow you to. So more or less, I think custom vision and computer vision can be used in separate use cases. If you want a more customized approach towards your models, then I would suggest you to work with custom vision. However, if you're just working with regular and general images, computer vision is your guy. So that's it. No problem, Nilay. I think there are no more doubts left. If there are any more doubts, then please feel free to put them up in the chat section.
So guys, if you have any kind of queries, you can directly put them in the live chat, and our speaker will be happy to help you out with the things. Do you want to ask anything? At least say yes or no in the live chat, please. So I guess there are no more doubts now. Guys, we are waiting for your doubts or your messages. If there is any, you can please put it in the live chat. Okay, so we have a reply from Nile. Nope, everything was covered very well. Thank you. We had a very nice speaker with us today. And from Anand Srivastava, he says, no, everything was explained. Thank you.
Thank you very much. So maybe
I think there was some problem with the Anubhav. So thank you everyone for joining the session today. And it was a lovely session. And we have got the feedback also from the audience. It was really nice session, and our speaker covered everything very well. So thank you, ma'am, for coming here and delivering such a nice topic on such a topic, which is not very easy to explain to everyone. So thank you for all your efforts, and thank you everyone for being such a lovely audience. We would like to see you for many other sessions, and ma'am, we'd surely like to have you again for other sessions on other topics as well. So thank you guys.